This podcast is sponsored by Click Playground. This free programming environment lets you explore and test your data-driven app ideas using Click's engine and APIs. The goal? Less query writing and more efficiency with associative indexing. Visit playground.click.com to learn more and see it for yourself.
Hello and welcome to another edition of the InfoQ podcast. My name is Wes Rice and I'm the chair of the International Software Conference's QCon, brought to you by InfoQ. In today's podcast, I'm speaking with Gene Barmash. Gene is the Director of Engineering for Compass, a technology-focused real estate brokerage out of New York City. Prior to Compass, he was the Vice President of Engineering for Thrift, where his focus was on building third-party developer platforms. Gene also is a co-founder and organizer of the CTO School Meetup in New York City and is a member of my program committee for QCon New York, which I might add as a shameless plug returns to New York City June 26 to 28. Today's chat focuses on binary RPC communication between backend services, specifically focused on experiences with Apache Thrift and gRPC. We talk a bit about code generation from Thrift. We talk about the design of public APIs, and we wrap up with some thoughts on lean and constraint theory applied to software systems and software people systems. So hope you enjoy the podcast. Welcome to the InfoQ podcast, Gene.
Thanks a lot, Wes. Thanks for having me.
So I guess we first met, it was 2015 at QCon New York, and I specifically remember at QCon New York. It was my first QCon, actually. But what I remember about it is you were running the architects you've always wondered about track. And I remember Micah Lemonick from Google, the guy who brought Google Sheets to Google, did a talk that was fantastic.
Yeah, no, that was a great talk. I still sort of come back to it sometimes when I speak to people.
Yeah, it was a really cool talk. So after then, you and I were chatting a little bit about architecture you've always wondered about for this QCon New York. You wrote this paragraph that sort of became the genesis for the idea of doing this particular podcast. And in it, you basically mentioned a cogen framework that you all developed at Compass that was driven around Thrift IDL, and later I know you adopted gRPC. So I'd like to dive into a bit on that experience, but before we do, let's kind of set the stage. Your role today is with Compass. Can you tell us a bit about Compass and the domain that you operate in there?
Yeah, sure. So Compass is sort of asking the question, if you were to create a brokerage, a real estate brokerage today, residential real estate, what would it look like? What would the marketing be like? What would the technology be like? And so we are a technology-focused real estate brokerage.
So what does that mean? So when you say a technology-focused real estate brokerage, what's that mean to me?
Well, so it really means that we think about overall agent experience. So agents are still kind of our superheroes. They're the ones that actually work with clients and help them buy and sell homes.
Right.
But, how do you insert technology kind of strategically into different parts of what they do? So, for example, one of the things that we've been getting a lot of press for recently is what Forbes called the Pinterest of real estate, and it's basically a collaboration tool that allows agents and customers to work on their search, right? So, agent can curate the experience for you. They're the expert. They can, guide you. They can help you. They can say, hey, this listing, stay away from because of whatever. And then here are some of the listings that, I think you really like. And the customer can do the same from their end, right? So you can comment on listings, specify what you like, what you don't like. So that's really a really great example of merging technology as well as real estate expertise from the agent.
So to use Pinterest terms, you like pin different properties and then you can collaborate back and forth with an agent?
Kind of, yeah. I mean, obviously it's a little bit different experience, but fundamentally, yeah. Here the idea is, you start wide, you start with, 50 properties, and then you will see some, and then you will understand what you like, what you don't like, and then over time you will narrow down your search into 5 properties that maybe you'll make an offer on 1 or 2 of them.
I see. So what's the stack at Compass look like?
So the backend, we are mostly Java and Python, and last I think year and a half we've been introducing Go. So Go at this point is pretty much also a first-class language for us.
Okay.
And on the front end we are Angular and Swift 3 on iOS.
So I'm curious about something. You mentioned that most of your services are Python and Java on the back end. What's driving you from something like Java to Go now?
Not necessarily specifically moving from and to. Is just we added Go as another part of the stack.
I see.
And here, I think the main reason also just developers, they tell me that they're more productive in Go. Even we have some developers that are, that were new to Go, but even then after a couple of weeks, they feel that they're more productive. They say that it's simpler. They say it kind of gets out of the way, and so that's one of the reasons. To be honest, I was kind of from the overall management side, I was a little bit resistant to going to Go, just because adding a third language in the stack is is not something that you want to do lightly. People are very happy, and Java is certainly still here to stay. We have a lot of Java. We'll continue to be doing Java, but some of the newer stuff, especially smaller services, people are very happy to write in Go.
As a developer, I love the fact that you have the freedom to choose the best tool for the given use case. But what about, I guess, the bootstrapping of an individual service and all the things that your enterprise needs? How is that kind of developer experience working for adding a new first-class language?
Well, yeah, exactly. That's kind of always the concern, right? Is that, you try to ensure languages and then you add a new one, and then, when you're in the middle of debugging, you realize that, I don't know, logging works a little bit differently or is not sent to the same place, or, it's not integrated with your telemetry or something like that, right? So fortunately, just because people were so excited, we're now over that hump. And by the way, like, one of the really interesting argument that I heard from one of our senior developers is that Go, because it's a little bit simpler, it is something that you can potentially, give access to your front-end developers to start looking at, versus Java, because it's higher ceremony, might be a little bit harder to do that.
What about the architecture itself? Are we talking a monolithic application? Obviously, you've got Java, Python, Go, so it's got to be broken up in some degree.
Yeah, so we're microservices architecture. I guess something a little bit different than my previous companies. We use RPC to communicate between services internally.
Yeah.
We started out with Thrift and Finagle, I think partially because some of the founding engineers from Twitter, and Twitter is the one that introduced Finagle.
Sure.
Over the last at least 6 months, we've been moving towards gRPC. And actually, it was interesting because since most of our services were already using Thrift, and gRPC, natively speaks protobuf, that was a bit of an issue. So we actually were able to use the flexibility that gRPC has, in that you can add your own protocols, and we made gRPC work with Thrift.
That's really interesting. So if I heard that right, you moved to gRPC, which I'm sure those listening know is an RPC framework, open source by Google, and makes heavy use of HTTP2. But you moved to gRPC, but kept Thrift's interface definition language aspect, the IDL aspect, and its binary communication protocol, rather than using gRPC's protocol buffers. Is that right?
Yeah, exactly.
So I'm curious, why?
That allowed us to both start taking advantage of the kind of newer programming model in gRPC, but still maintain all the backwards compatibility for the services that that we've been using for the last several years.
That's pretty cool. I guess I hadn't heard of anybody keeping the Thrift protocols in place when adopting gRPC. What was that experience like?
From what I can tell, it wasn't too bad. We had a couple of engineers working on it, some of our senior engineers, and they did it, I think, in about a month or so. Okay. Along the lines, they also wrote a Thrift linter, which we open sourced, and so it wasn't too horrible. I think they found gRPC a pretty nice framework to work on, and of course, the fundamental programming model of RPC was similar.
What does that mean when you say the fundamental programming model was similar between Finagle and gRPC?
Well, that both are RPC frameworks, so they try to achieve some kind of binary protocol over the wire. They both have a concept of error handling. They both have the concept of, like I said, forwards compatibility, right? So it's not like trying to introduce REST into gRPC, which would probably be a very different programming model.
So let's talk about that migration for a second. Actually, before you do, We've been talking about Finagle and Thrift, and I guess it kind of makes sense to kind of make sure everybody knows what those are and level set. Finagle is a JVM RPC framework, often used to build microservices. And as you mentioned before, it came out of Twitter. While Finagle, like you just mentioned with gRPC, is protocol agnostic, and many people often use it with Thrift. Thrift, as you probably already figured out from our conversation, uses an IDL or interface definition language file that then goes through a code generator that generates client and server RPC libraries for a variety of different languages. What actually goes over the wire is binary. So it's binary rather than something like JSON that you might find in a HTTP RPC library. All right, so now back to my question. So you mentioned you were using Finagle and Thrift, and now you're using gRPC. What drove that decision? What made you move?
Well, so I think I think at some point we realized that most people, most of our backend engineers weren't actually experts in Finagle, using a lot of its features, but people were a little bit more interested in gRPC. So we started to move to it just partially to get our stack to a little bit more modern place. And so that was probably the primary motivator.
So what did you see as some of the improvements that you gained with gRPC and Thrift over using the Finagle Thrift stack?
Yeah, I think what we're seeing gRPC as kind of very analogous, but also having some additional capabilities around things like error handling, and just generally there's more momentum around gRPC. So from a long-term perspective, we thought that it would be a good move.
Sure.
And also once again, I think people were more excited to learn about gRPC.
What about from a performance perspective? I've read a lot of things about gRPC having a significant performance improvement over at least HTTP RPC requests.
So performance wasn't really kind of a key driver here. So I'm actually not even sure, to which extent we even measured that. We didn't necessarily have like huge performance problems with Thrift and Finagle. It was just more like, once again, I think the Finagle programming model people found confusing, and so it was more around kind of developer experience. That was the core.
So let's talk about that developer experience a bit. What did you see differently? What do the developers think about going to gRPC?
Well, developers certainly like it a little bit more. We're still in kind of the middle of rolling out, so certainly some of the developers that were behind the rollout definitely thought that it was a better programming model. But we're still kind of going through the training, still ironing out a few issues with some of the services. So we are probably like 80% converted in terms of number of services to use gRPC, but then still have about 20% that's left over.
Can you give me an idea of the kind of scale of your backend? Is it how many, if you were going to put a number to the services, how many are we talking about?
I think probably about 40 to 50 services, rough order of magnitude.
One of the common issues around REST are managing schema changes. Those problems really start to go away when you're using something like Thrift, gRPC, or Avro because of the idea of schema evolution, or the ability to evolve a schema without redeploying the client and server libraries. So you mentioned one of the big changes between where you're at now and some of the other roles you had before were the idea of using an RPC library on the back end between services. So has that schema evolution kind of worked as advertised for you as you've moved?
Yes, I think so. Like a certain type of problems that you would get using REST just sort of go away. Now, in the past, the places I've been, they've used REST without something like RAML or without code generation frameworks. So that may also help you as well, using REST. But unless you do that and you don't really have a schema, then you do need to think about versioning. You will get you will roll something out, and then the clients are not ready for it. With Thrift and I guess probably Protobuf as well, they sort of thought of that problem, and they're forwards compatible. So even if you start, making calls for a new API that the server doesn't support, it will do something intelligent in that case, right? Where in REST, there's just no real standards around that.
All right, so I mentioned at the very beginning the kind of genesis, the reason I wanted to do this is this statement, I'll read it. It's we created a pretty cool framework code generation from Thrift. It basically takes Thrift RPC protocol, which we talked a bit about, and it converts it to RESTful API and then generates client code in a variety of different languages. So tell me about that framework.
So because we use Thrift internally, we have a bunch of services that are already written and basically have, highly structured APIs. Thrift has its own language, which we ended up parsing and using that as the basis for code generation. So we looked at that. We had a new mobile app that we were building, and so we decided. Oh yeah, and also another reason, by the way, why we moved to gRPC is also to enable using our RPC framework in different languages that we support. Thrift was mostly Java and had very poor Python support. So basically, we looked at our needs and we realized, well, what if we take Thrift and basically convert it, using some kind of convention to a RESTful API? And so we put together a proof of concept. People liked it, and then we kind of went forward the whole way. So the way the framework works, once again, it looks at the Thrift files. We created like basically convention/annotation in the Thrift files where you can, for example, say, this Thrift service maps to this RESTful endpoint. And then we basically, parse that, generate abstract syntax tree, and then from that go to code generation. And then the code generator basically will take in a template, which, by the way, teams can customize and have customized for their own needs. That code generation we do in JavaScript, in Swift, and in Java/Kotlin for our Android development. And then we also generate RAML as well for documentation.
Now, is this for public-facing services or internal services?
So we don't really sort of have publicly facing services, but our web and our mobile works off RESTful services. So they're kind of public, obviously, but yeah, so that's how that works.
So inter-service communication on the back end is all gRPC, traditional gRPC, but anything that the clients are consuming is JSON.
Exactly. Mm-hmm.
So prior to Compass, you were the VP of engineering for a company called Tradeshift. There, a lot of your work was focused around developing public APIs, specifically building a developer API platform. Contrasting that a bit with some of the work at Compass, what types of things are really different when you're building for a public versus a private API? Ideally,
there wouldn't really be a humongous difference between them, right? At the end of the day, you have other programmers that are consuming those APIs. Mm-hmm. So certainly, having good conventions, having, thinking about how to simplify the APIs, thinking about ways that APIs kind of look natural for people to use and match their mental models. Yeah. Pretty much, the same. Now, in practice, of course, when you are opening up a public API, you have much less control. And so you probably should work much harder in simplifying, right? Because you can fix a mistake that you made in an internal API, but once you have at least one or two clients using it, you really can't fix it for public APIs.
Yeah, I think was it Joshua Block that a public API is forever?
Exactly, yeah.
If you would, from your experience, would you walk me through some of the things that you consider when you're designing a public API? What has your experience showed you?
I think a lot of times that it does actually start with an internal API, right? Because you probably do have some internal clients for at least some of your APIs. So using that to inform is important. Otherwise, I think looking at some other great APIs, thinking about, what are the core concepts that your users, that you want to expose to the users, and are they going to make sense to them? Thinking about what is the extensibility model, right? Because when you're exposing it to external developers, they're usually trying to extend something, right? So does it make sense within the overall extensibility model? So for example, at Tradeshift, we had certain APIs, that you could just call. We had some webhooks that you would also be able to call, right? And so what does the overall experience look like? And which parts should be done using which technique?
How do you kind of answer the question or address the fact you can't please everybody? How do you deal with that?
I guess I don't know. I think I'm not sure. I'm not sure if I was fully successful in that. But I think always a good bet is to working with the clients that you have, trying to get feedback from them, being open to their criticism and being able to adjust. And then of course thinking about versioning, thinking about how you're going to evolve the API over time is obviously hugely important. So if you have a strategy for that, if you have technology for that, then even if you make some mistakes, you can fix them.
I see. Okay, so one of the other things I wanted to talk a bit about is you're also the co-founder or one of the founders of the CTO School in New York, right?
Yes.
So what's the CTO School in New York? What's its goal?
So its goal is sort of both to educate and bring together different technical leaders so that we can all become better technical leaders.
Yeah. I remember I saw a tweet you had, I guess last year sometime, and it talked about how much you enjoyed Jez Humble's talk on principles of lean product management. So lean's a big part of some of the things you're interested in, right?
Definitely, yeah.
So what about lean attracts you to the concepts and practices?
Well, so especially from the management side, kind of both product and engineering management, I think it gives you a very sophisticated framework to think about making certain decisions, thinking about velocity, engineering velocity, and how to optimize it. And at least one of the books that I read, which I always recommend to anybody that will listen, is Don Reinert's Principles of Product Development Flow. When I read that book, I think it sort of felt like I really understood some of the theory behind Agile and kind of different flavors of Agile. So it was kind of very eye-opening for me.
Can you give me an example of something in the book that you really got?
Yeah, so for example, it talks about setting up cadences, right? Which, the nice thing about setting up cadences, let's say a weekly meeting, monthly meeting, or something like that, is that it minimizes overhead around scheduling that meeting. So let's say if you decide you're going to have a design review or engineering review, let's say every Friday at 2:00, well, everybody knows it, right? So you don't need to count people and stuff like that. A lot of it is also about breaking things up into smaller chunks and why that makes sense. It talks about kind of asymmetry of innovation, which I thought was very interesting, that as long as you're able to cut your losses in kind of an experiment that you're doing, that's a finite, let's say, loss. But if you have an idea that pans out, then you can make millions of dollars using it, right? So keeping in mind that you have this asymmetry in a lot of the stuff that you do in software is certainly interesting and hugely important. Also, I'm reminded, when I think about that, I'm reminded of a really great talk by Roy Rappaport, I think UConn San Francisco, I believe, where he went through something like 10 different projects that he did in the previous 18 months and rank himself to, which ones have been successful, which ones have been failures. And about 50% of them basically were, either complete failures or just weren't necessarily something that he would consider a success. And so, he asked the question, he's like, well, so my job is to be really good at this stuff. So is this, am I doing well?
Yeah.
And the argument that he made is that for the losses, they were contained, right? Maybe a month of development each. But for the wins, it was something that was continuing bring value on month-by-month basis.
True.
And so I think to me that really demonstrated kind of the asymmetry. I mean, he was talking about kind of investing in developer tooling and stuff like that. And of course, that's applied there as well as on the product development side.
It's really interesting. But using lean principles, how do you do just enough to validate that the project or the idea is worthy of pursuing?
Well, I mean, I guess that is the art of it.
Yeah.
Figure out when to cut. But one of the things I've been doing more recently with some of my teams is we've been doing proofs of concept. That's a really good example because it both helps you validate that what you're thinking about makes sense, and then just helps you understand the problem. So that once again, here the focus is learning. The focus is not necessarily we're going to put this to production immediately, but it's more, do we understand the problem well enough so that we can make better decisions? And maybe we'll decide this is not the right approach to pursue because we realize that this thing that we're about to do is like really, really expensive for whatever reason.
Sure.
So some of it is about cost, some of it is about opportunity.
Yeah, well, there's an art there too, right? How do you manage expectations? Because once you build that prototype and the customer management see it, and it's like, well, it's working, right? So let's put that into production.
Well, yes, I mean, sometimes that obviously does happen, but here I'm talking about more like experiments within the project. So kind of like, hey, let's see, like, for example, we're building this system for enabling WYSIWYG collateral creation. And we started working with print, but then we knew that one of our goal is to eventually support email. So we put together a little proof of concept with email just to make sure that we understand that use case. And a few people that saw it got really excited. So maybe some other teams might be able to reuse that because they have some similar needs around, what you see is what you get editing.
Yeah, makes sense. Another thing you and I've talked about is kind of theory of constraints as applied to both software and to people systems. Can you talk a bit about that?
Yeah, so, to me, like there's sort of a bunch of related disciplines around lean product development, constraints theory, and I guess systems thinking, which I'm still fairly new to. But, the idea behind constraints theory is that any system will have basically only one constraint that impedes its kind of increasing its throughput. And that can apply to both systems as well as people systems, like engineering teams. Now, in the engineering teams, you might have a little bit more flexibility, but still, I think the main concept applies. So, for example, maybe your team, doesn't have enough front-end engineers right now, right? So that means you'll be constrained with delivering certain types of valuable features and valuable products based on that constraint, right? So the constraints theory kind of gives you some thoughts about what to do in those situations. And that is to, first of all, identify that constraint, and then thinking very, very hard about, now that I've identified this constraint, how do I kind of manage that constraint? How do I, for example, make sure that person, let's say, let's use the extreme case that you only have one front-end developer. So what do you do then? Well, first of all, you need to be very careful about making sure that they're doing the really most valuable things, number one. Number two is, do you ask some of your backend engineers that have some JavaScript experience to start picking off some of the simpler tasks, right? Still makes you more productive, still increases your overall throughput. Then you think about, well, let's say I have 30 engineers and only one of them is front-end engineer, right? All of a sudden, bringing in a second contractor, even if their cost, even if they're very expensive, to unconstrain the system and to allow you to deliver value quicker starts making more sense, right? Yes, they're $300 an hour, and that's obscenely expensive, but let's weigh that against the fact that I have, out of my 30 developers, 10 of them are basically sitting idle and working on things that don't quite make it to users. All of a sudden, that equation starts shifting very quickly. And so I think recently applying some of that thinking to thinking about how do you do hiring, how do you do prioritization, how do you do planning, is something that I found very interesting and very useful.
Yeah, it's pretty cool. I mean, it goes back to Eli Goldratt's The Goal, but applies it to software and to working with people today. That's an interesting take on it.
Yeah, and I think Goldratt, obviously, he did sort of apply things originally to manufacturing, but I think certainly he was thinking about things, from a wider perspective, and I think he also understood that systems can be defined in many different ways.
Yeah, sure, absolutely. So I kind of started off that you're running the architecture you've always wondered about track. In 2015, you're running it again this year for QCon New York. Any spoilers that you can tell us about what you've got in store? Yeah,
so I think basically when I try to plan that track, I usually come up with like 30 different ideas because I think there's so much stuff out there that's interesting. Yeah. So some of the stuff that I think we'll probably have this year, or at least we're getting close to, is have a great talk on IoT in planning, which of course is something that I think many of us have been hearing about, but haven't necessarily been able to like grok it sufficiently well. So that's one. Another one will be focused on event-driven architectures, which I think is another thing that sort of has been there for several years, but there haven't really been too many, large-scale production use cases to highlight. So those are the couple of ones, and still, reaching out and thinking about a few others.
Yeah. So when you talk about IoT, you talk about lots of sensor data coming in. What's the focus on that?
Yeah. So I think some of it is about sensor data, of course, but at least the one talk, which looks like it's going to pan out, is going to be about basically combining some IoT sensors with some server-side processing to, once again, really think about a particular domain, in this case, most likely kind of kitchens and fast food restaurants, to give you a little bit more of a sneak peek as an ecosystem, and thinking about, well, you have humans, you have machines, you have servers that are able to do certain types of computation, you have sensors. And so how do you really take advantage of all that to optimize once again, back to the throughput of the system, which in this case is, food for people that are hungry.
And this is for software developers, right?
It is for software developers, and there's certainly some interesting things in there, both from the IoT side, both from the kind of identity side, right? Because each device has to be identified and and kind of work in concert, as well as some deployment challenges around the fact that a restaurant can go down, but you still need to be able to operate autonomously from kind of some centralized hub. So it's a surprisingly interesting set of challenges that you have.
Yeah, sounds like it. Well, if you like what you heard and you have more questions for Gene, be sure to join him in person at QCon New York this June 26 and 28. We'll be at Marriott Marquis at Times Square for QCon New York this year. Or if you're local to the New York area, be sure to join Gene at one of his CTO School Meetups. Well, Gene, thanks for taking the time to chat.
Of course.